Introducing Willow, Google's breakthrough quantum chip. With 105 qubits, it scales the quantum frontier, a breakthrough in error reduction, outperforming classical computers by 10x leap in quantum computing. Google Willow, scaling the quantum frontier. A 2024 breakthrough beyond classical, paving the way to millions of qubits, revolutionizing
scaling
computing.
the quantum frontier, achieving 1000x better error suppression, surpassing classical limits. This unlocks new possibilities in quantum simulation and AI, redefining computation technology. Willow scales the quantum frontier, delivering a million-fold speedup over classical systems. It suppresses errors exponentially. This advances toward practical applications, transforming technology's
right now,
future.
The encryption protecting Bitcoin is mathematically impenetrable to modern hardware. But Google claims that once their quantum computer is fully operational, it will be able to crack that exact same encryption in just 9 minutes. To understand how that kind of speed is possible, we have to look at how we process information today. Everything from your smartphone to the massive NVIDIA GPUs running the latest AI models operates entirely on classical computing. They process data in strict binary, reading every single piece of information as either a 0 or a 1. And we are hitting a hard physical limit with those zeros and ones. Even with thousands of classical processors working perfectly in parallel, computing the complex molecular structures needed to cure certain diseases, or reaching true artificial general intelligence, would still take decades to process. This is the exact bottleneck that quantum computing bypasses. Instead of relying on linear binary bits, quantum computers use qubits. Through a property of quantum mechanics called superposition, a qubit doesn't have to choose between being a 0 or a 1. It can exist in multiple states at the exact same time. This means it can process a vast array of possibilities simultaneously, instantly calculating thousands of potential outcomes instead of checking them sequentially. This is an entirely separate architecture for calculating reality. By utilizing subatomic physics to process data, quantum systems move beyond the linear limitations of our current silicon-based logic. Building a machine capable of maintaining those quantum states requires extreme physical environments. To keep the hardware stable enough to perform a calculation, the systems are housed inside massive cooling towers operating at -273 degrees Celsius, colder than deep space. That deep freeze is mandatory because qubits are intensely fragile. The slightest fluctuation in temperature or background radiation causes immediate calculation errors, making the system highly unreliable for sustained tasks. Solving that instability has driven a massive global research effort. The modern race gained serious traction in 2019, when Google first successfully demonstrated a working quantum concept to the world. Over the next 4 years, researchers focused heavily on writing specialized code and tweaking hardware to tackle the error correction bottleneck. By 2023, the first prototypes emerged that could successfully mitigate these faults, keeping the qubits stable enough to produce reliable output. Proving that the error rate could be controlled was the mandatory first step. Before any lab could scale up the sheer speed and computing power of these chips, they had to prove the math wouldn't collapse mid-calculation. Once that stability was secured, the hardware capabilities expanded rapidly. In 2024, Google unveiled the Willow chip. In specific benchmark tests, this hardware proved to be 13,000 times faster than the world's most capable classical supercomputers. Looking toward near-term developments in 2026, the strategy is shifting to scale. Google is actively planning to introduce neutral atoms into their designs, a method specifically targeted at multiplying the total number of qubits a single chip can handle. This image shows how complex the early prototype hardware configurations are laid out to handle these precise quantum states. It requires an incredibly dense arrangement of microchips and resistors, and the physical footprint of this research is expanding globally. Through the National Quantum Mission, countries like India are already creating dedicated research and development testbeds right now in the landscape of Andhra Pradesh. Yet, for all of these massive processing leaps across continents, the actual technology remains physically trapped inside highly specialized, heavily controlled laboratory environments. The active goal is to pull these machines out of the lab. Both Google and IBM are targeting a window between 2027 and 2030 to finalize an industry-grade, perfectly functioning quantum computer. When that happens, the first practical impacts will hit medicine. Pharmaceutical research that currently requires years of physical trial and error and billions of dollars in funding will be simulated and perfectly mapped out in mere seconds. Then comes the technological convergence. Researchers are preparing to mate the immense parallel processing power of these quantum systems with the AI algorithms driving today's large language models. This convergence leads toward theoretical targets like artificial general intelligence. If quantum speed can provide the processing overhead required for human-level reasoning, researchers believe it could eventually lead to machines that simulate cognition at scales we can currently only imagine. However, we won't see a quantum server in every city's local data center overnight. Scaling this fragile technology out of the lab for mass commercial use will take time, pushing widespread global adoption to years 2035 to 2045. We are watching the initial buildup of a completely new computing architecture. When the hardware finally matures, the transition to quantum mechanics and chips like Google's Willow will be remembered alongside the original silicon microchip as a defining milestone in human innovation.
Google Willow. Willow achieves exponential error suppression below threshold. This milestone builds on Sprint's breakthroughs. Google Quantum AI leads the way to practical quantum applications.